Hello, welcome back. Our next talk is titled KubeInception, running up to 1,000 clusters in a real cloud-native way, and our presenter is Dario Tranchitella.
Perfect. So, welcome to my session. So, my name is Dario, and I'm really happy to be here. So, in this beautiful Bratislava. So, I'll try to introduce briefly myself because you're pretty tired because it's Sunday, so we should rest. And instead, you're here listening to my talk. So, my name is Dario. I'm doing technical advisor at Classics. You can find my details here about Twitter, GitHub, and so on and so forth. But there is a spoiler alert. So, I'll try to keep you awake. So, memes are on their way. I'll try to explain what we're doing at Classics because I'm technical advisor and I'm also one of the core maintainers for our open source projects. So we are the leaders of multi-tenancy, according to me, so I'm a bit biased, but we are helping companies addressing cloud-native solutions, especially addressing multi-tenancy. And for whom of them they were yesterday here, we talked about in a lightning talk session about what is multi-tenancy, and I try to keep it short. So keep in mind that with multi-tenancy, it means that you're sharing an infrastructure or maybe your application, but since we are here talking about Kubernetes, we are referring to the infrastructure. So it means that you have to control the resources and also to enforce the isolation. So we got multiple levels of multi-tenancy. So to keep it short and simple, because there are 50 shades of gray of multi-tenancy, not that kind of grays you can imagine, but we got the soft one and the hard one. So the soft one is like having namespaces, okay? So we already have namespaces in Kubernetes, but maybe I want to group together some namespaces in a tenant abstraction. So you can imagine maybe a bank or a huge corporation that is using Kubernetes, and they need to share resources across multiple actors, multiple users. And the hard isolation is slightly different, and it's even simplified because in the end, you're providing a Kubernetes cluster per each tenant. So you can imagine the bank that is providing a Kubernetes cluster for each group of developer. So the old approach and the classical approach is one cluster per tenant. So if you think about that, it's really good because it's that simple. Everybody can understand that. And I'm pretty sure that some of you are already running multiple Kubernetes clusters in production, maybe for different tenants. But there are some downsides. And downsides is that managing a fleet of Kubernetes clusters is really challenging. So it means that you need to operate them very well. And also, you're wasting resources. Because if you think about also the control plane. So the control plane, we are going to talk about that. So I'm referring to the etcd, scheduler, controller manager, API server. So cost, governance, observability, and also cluster sprawl. So our buzzword, right now we are always talking about platform engineering, but we can talk also about cluster sprawl. Cluster sprawl is our buzzword. So buzzword, it means that, well, not buzzword, but the cluster sprawl means that we are running multiple clusters. But I'm not able to explain that. So this is the first meme. So you can imagine that you have your departments, they're asking a cluster. So I've been a site reliability engineer, and that was my honest reaction when they were asking for multiple clusters. So it's really painful to manage. But let's try to understand how it works running multiple clusters. So it means that, as I said before, we are running 3 virtual machines, at least 3, because we got etcd that is based on the Raft algorithm. And then, obviously, there are no free lunches out there, so it means that we have to manage those control plane. So what it doesn't mean, manage. So we have to rotate the CA, it happens by 10 years, but you have to take care of that, but also about the certificates. Then you have to ensure high availability, so it means that you have to create a virtual IP for the API, you have to be sure that the F checks are working, and so on and so forth, and you have to perform upgrades. So yesterday was really helpful also attending a talk where we were talking about upgrading the Kubernetes clusters. So it's not so much easy. It's not like, oh, I click a button and the new version of Kubernetes is out there. It will be really cool, but it doesn't work that way. And also, you have to keep the desired state. So you have to be sure that all the kubeadm configurations are deployed in the cluster, are configured properly, and also all the components and blah, blah, blah. So multiple clusters are okay, but obviously keep in mind that we are not talking just from the compute perspective or from the, I would say that, from the operational. But the problem here is that we are people and we have to take care of those clusters. And it means that we are ending up with a linear, and I'd say even not properly linear, but a quadratic exponential burden. I've been there, I done that, so I know what I'm talking about, I guess so. And besides that, also, you're missing the governance, control, you are doing a lot of repetitive tasks, and when you're doing the same thing several times, we are humans, and likely I'd say, so shift happens. So I didn't say a bad word, but you are getting the point. So let's try to understand the negative outcomes of the multiple control planes. So essentially, we are ending up with a new concept that we try to create, that is the Kubernetes control plane tax. Because in the end, you know that there are some components in Kubernetes that are not able to scale horizontally. So we got the Kubernetes API server that essentially is an HTTP endpoint, like any application, but controller manager, scheduler, they are working in a vertical way because there is a leader election. So it means that you're ending up just with a single virtual machine that is doing the hard job, so the other two are there just to be ready when there is a failure. So you're wasting resources. That's the tax. And also, you have to take care of those clusters, although you can put in place automation, but those automations must be written by you and they must be run by you. And also, the last point, technology scales, but people don't. And there is a meme that is trying to explain that. So I don't know whoever of you saw Dune or is reading Dune. It's one of my favorite books. I'm at 6. And that was me essentially, because I've been a site reliability engineer, and I wasn't called for 3 weeks, but you're getting points. So taking care of Kubernetes clusters is really painful, like the Ben & Gesserit box. And let's talk about the downsides of running multiple cluster, I'd say multiple control planes, because that's the topic of this talk. So each control plane requires at least 3 virtual machines, and we can try to do some maths. And the math is running on AWS, because it's one of the most popular hyperscaler out there. And I try to engage with the community because it's part of my job, and I really love to engage with the community. So please stop by outside the speaker room so we can talk about that. But we figure out that essentially one control plane on AWS, not a managed Kubernetes cluster, is going to cost you something like $300 per month. And it's a quite sizable amount of money. So you're spending resources, but we are going to spend also time, because maybe what you can do is to say, okay, I can buy the managed service by AWS. So you have to wait up to 11 minutes. I'd say it's pretty reasonable, okay? 11 minutes is not so much. But from my perspective, it's a lot of time. And this is another meme, I'm sorry for that. But it's Alonso, a Formula 1 driver, and he's doing a awesome season this year. But also, you're missing people. I don't know what's the situation here in Czech and Slovak, but especially in Italy, the country where I'm coming from, but worldwide, say, we got a shortage of people because people, they don't want to manage Kubernetes. They prefer doing something else. So finding people to take care of your cluster is really painful. So I want to introduce my second open source project, to be sure, to be honest, that is Kamaji. So what is Kamaji? So long story made short, it's a reference to Studio Ghibli movie, Spirited Away. And we like this name because essentially Kamaji is hiding a lot of the complexity. And essentially, it can provide you a tenant control plane in a matter of seconds, like you see in the movie, where Kamaji is the boilerman, is providing the hot water to the guest. So let's try to understand the features, and we can talk also from the technical standpoint. The benefit of Kamaji is essentially provide a self-service Kubernetes, so you don't need to engage with different providers. You got just a single entry point that is Kubernetes-based. So you're using the Kubernetes API server or the same manifest you are expecting. So it's YAML, everybody loves YAML. And then it provides also cheaper control planes. So we are running the control plane as pods and not like virtual machines. And virtual machines are pretty cheap, but pods are cheaper. And we are running the Kubernetes-inception. So Kubernetes-inception is our buzzword because we are running Kubernetes in Kubernetes. So this is the KubeInception. Why we are getting benefit from that? mostly because we can take advantage of all the machinery offered by Kubernetes. So we got the event loop, the reconciliation. We can use the primitives, the native primitives of Kubernetes. So it's really great because we are able to create an operator and run Kubernetes in a native way. And then, obviously, we are ending up with multi-cluster management because the main pain point is managing all these clusters. And we are providing also stronger multi-tenancy. And we are going to talk about that with the data stores. And mostly, it's not yet another Kubernetes distribution, but it's plain vanilla CNCF conformant Kubernetes cluster. So let's briefly talk about the architecture. So we introduced two CRDs, custom resource definitions. They are objects that allow to extend the Kubernetes API capabilities. So we got the tenant control plane that are essentially our API endpoint, and then we got the data store. So the data stores are the objects where we are storing all the Kubernetes objects. So etcd essentially. But we are not talking just about etcd, because as you can see here, we got multiple options to run the data store. So we can use bare etcd, we can use MySQL. Oh my gosh, please don't use MySQL. Or rather, what you can do is to use PostgreSQL. And as you can see here, essentially, we are ending up with a management cluster that, in our jargon, we call it admin cluster, but you're getting the point, where you can define the control plane. So the tenant control plane are pods that are connecting to one multi-tenant data store, and essentially you can bring your own nodes. And this is something really interesting because it doesn't mean that you need to run everything on the same infrastructure. So what you can do is to achieve a multi-cloud provider Kubernetes solution. So you can run the worker nodes on vSphere, on AWS, on Azure, on Equinix, whatever you want, even on-prem. So this is the simple architecture because, as I said before, the control plane is running as pods. So it means that we're ending up with a single pod that is containing the API server, the controller manager, and the scheduler. etcd is out of the equation here because it's the data store, and you can manage etcd in different ways. So it could be deployed inside of the cluster, or you can use PostgreSQL. So you can use an operator like the Cloud Native PG developed by the people at EnterpriseDB. It's not shameless self-promotion, but it's an open source project that's going to be donated to CNCF. But keep in mind that the idea here is to decouple the stateful data from the stateless components of Kubernetes. So the stateless components, they can be treated like any regular application running in Kubernetes, because in the end, the control plane is the API. So we got an HTTP endpoint, and then we are saving the data in a database. So yet another Kubernetes solution, say, well, no, I'm sharing my insights, so I'm a bit biased about that. But keep in mind that I've been a bit experienced on running Kubernetes in production, so I try to design something that will be really helpful to the people that is doing what I was doing as a job, so as a site engineer. And also, I didn't want to be opinionated, so it means that it's a sort of framework, so you can use that in the better way you consider. So what you can do is to have one-on-one relationship between the tenant control plane and the data source. So you got 100, well, I'd say 10 control planes, so it means you're running 10 etcd clusters, or what you can do is to have one etcd that is hosting up to 10, 20, 50 tenant control planes. It's up to you. And most important, you're bringing your own nodes. So it means that you're decoupling also from the infrastructure. So you just need to use kubeadm to let the worker nodes join your tenant control plane. And you're doing also the offloading of scaling and reliability, because essentially it means that there is Kubernetes doing all the black magic on your behalf. So it means that I don't need to create the certificates. I don't need to perform all the DAO stuff. So what you have to do is to apply a manifest. And Kamaji is doing all the DAO job on your behalf. So even the updates. So you don't have to take care of that because it's the operator doing that. And most important, there is a nice project that is named Cluster API. We had an interesting talk about Cluster API. So essentially, Cluster API allows to run Kubernetes to define Kubernetes clusters as Kubernetes resources. So we are working with the community, and you can engage there. It will be really helpful also having your thoughts, your view about the project. So we can talk about that on Twitter or in real life. And fast and cheap. This is the most important stuff, because I don't want to wait hours to get my cluster up and running, and I don't want to spend a lot of money. So is it really fast? So I think that we got enough time for demo, or at least I hope so. So right now, you can see here, I got my cluster. It's a Kubernetes in Docker, but it's a regular cluster. I got several CRDs, and you can see that we got the tenant control plane. And now I'm going to show you how many times do we have to wait for a tenant control plane. So I already have a manifest. So it's here. Oops. Config manifest config samples tenant control plane. You can see here this is our definition, 2 replicas, load balancer, 124. And what I have to do is to apply this one. And let's try to guess how many times do we have to wait. Now I'm sweating because I hope it works, you know, the demo effect. Yeah, it was a bit slow, 18 seconds. And with 18 seconds, it means that if I try to get the secret containing the admin kubeconfig, I can download it, and I can use this one. So kubeconfig, kubectl version. You can see here 124, and it's 124. So really fast and cheap because I got just 2 pods. This is my control plane. And the next challenge is, can we make it cheaper than EKS? You know, because EKS is one of the most used managed Kubernetes service out there, used according to one of our latest reports. It sounds like 40% of Kubernetes clusters are running on EKS. And you know, it's not cheap because, well, it's cheap if you think about that, but you are going to spend something like $75 per month. So it's peanuts, because you can imagine a salary of a guy or a lady running, doing Kubernetes and DevOps stuff. So this is the challenge. Keep in mind that this is just an exercise, and it was also a sort of benchmark for us as developers trying to understand if Kamaji is performing well. And I'm going to share with you also some insights that could be really beneficial for you if you're running at scale. I was doing that, and that's the reason why I lost all my hair, but that's another story. So keep in mind that what we did is to create different node pools. So we were running a separate infrastructure node pool just for etcd, because etcd is the crucial part of the whole infrastructure, because etcd, they need to have high performance storage and high performance also network. And then we were running also the workload node pool where the tenant control plane pods were deployed. And these are all the insights about the performances, the amount of resources. Keep in mind that our idea was to say, let's create up to 8,000 of tenant control plane. So it's a sizable amount, I guess. So I hope that I can impress you. It seems so. You're so silent, but I think so. And then obviously we wanted also to monitor everything, because if you're running something in production and you're not monitoring, it's like, you know, sailing with eyes shut down, so closed eyes. So it's really dangerous. And then also I have to share also another insight from my former experience. So we just use etcd. I told you that you can run PostgreSQL, and keep in mind that I cannot say that due to the NDAs, because getting in touch with the community is really helpful, because you have the chance to talk to a lot of engineers, but it means that you know even some secrets. And keep in mind that most of the managed Kubernetes services, they are not running on etcd. So it's a shocking news, you know, but they are not running on etcd because etcd got so many limitations. But just for the sake of simplicity, we are using etcd, and a pattern that when you talk with system administrators, they don't like it, and it's the sharding. But keep in mind that you cannot run a huge infrastructure, but rather it's more reasonable having a sort of shard. So our idea is to say, let's deploy 100 of tenant control planes per each etcd instance, so for each data store. And then obviously we weren't using a GPT volumes on AWS, but rather we were using the local path provisioner. So we were using the local storage of the virtual machine. And I want to show you what I saw monitoring etcd, so with the Prometheus stack. And this is really interesting because, you know, it's really hard trying to create such infrastructure because you're spending a lot of money, and we are going to talk about money because cash is king. But you can see here that essentially with etcd, this etcd was containing 100 of tenant control planes, and you can see here that the keys are increasing because obviously I wasn't creating everything together, but rather I started doing a sort of backup because otherwise, you know, bad things can happen also in regards to the bottlenecks of the network. But also the traffic was pretty good, and also the sync time was pretty good. And other information that were really important is the fact that the DB size was getting increased in a linear way, so it was working mostly perfect way, and also the compacted size. So I'm not saying that you have to run 100 or 1,000 of control planes in a single etcd, but it really depends, you know. There is a joke. I always say that you can measure the seniority of a professional by how many times it depends. But I don't think I'm senior. I'm trying to do my stuff. And yeah, also another important metric, especially with etcd, is to check the sync duration in the disk, because this is pretty important because etcd is really I/O bound, so you have to check that the storage is pretty fast enough in writing to the database. And also, take a look here to the network, and it was really interesting because we were ending up sometimes in writing not so much data because it was just 125 megabytes per second, but it was pretty interesting seeing these metrics for etcd. But obviously, let's talk also about Kamaji, because etcd is just a part of the combination. So let's try to understand how it works. So the first metric that I really love is the network I/O pressure of Kamaji. So you can see here that at some point when we were fully up to 1,000 of clusters, we had 200 megabytes per second from the network. So in and out, because we were reconciling a lot of objects, because we got the deployment, we got the service, we got the config map, we got the secrets, and each secret is containing the certificate authority, the front proxy, the API server, the kubeconfig for the controller manager, the kubeconfig for the scheduler, a lot of resources. But more important, I was checking also the CPU and the memory usage. And you can see here that we are not talking about madness. I mean, the maximum amount was 2 virtual CPUs, so up to 1,000 clusters. So it means that was pretty good. And also, take a look to the memory. So essentially, Kamaji is totally written in Go, the same language runtime that you are using when you're using Kubernetes. And also the memory usage. Here, we were barely at 8 gigabyte of RAM. So I'd say really good. And also, in regards to the Pulse network, here we can see that we got some spikes because we got the objects, the local cache of Kamaji that was getting populated with new data. But I'd say that it doesn't sound like an application that is managing 1,000 of tenant control planes. So I want to give you some insights that I discovered doing this benchmark. Sharding is required. If you want to scale to infinity, I got a bad news for you. It's not going to work. And also what you have to do, but it's pretty trivial, but try to automate everything, because in the end, if you're able to automate something, also the infrastructure, it means that you can make it repeatable, and it means that you can make it less error prone. And also the fine-tuning. The fine-tuning is really challenging because, you know, especially for the applications, if you think about that, you got the dev, and then you got the QA, and you can have also the benchmark environment. but production is the real playground. So it was nice, at least for me as core maintainer and developer, having the chance to give a try in a real production, also because Kamaji is trusted by companies that are using that in production. But it was really cool because I had the chance also to find and add some parameters to the runtime of Kamaji in regards to optimize the reconciliation. And last but not least, although we are talking about cloud because the test was run on AWS, you have to take the right hardware because otherwise you're getting so many troubles. So you have to think about in advance about the network, the storage, and the compute, especially for Prometheus. I still remember that the first try running 8,000 of clusters, I had so many issues with Prometheus because Prometheus was ingesting a lot of data. And let's take a look also to the takeaways from the financial standpoint. So we decided to go for 8,000 of control planes, and it means that on AWS you're going to pay up to 75,000 euros per month. A lot of data, a lot of money, you know. And instead, with Kamaji, essentially, we were able to replicate the same experience as an EKS because essentially it was totally managed in it's a lot of money, but barely 23,000 euros per month. And you know, it's a saving up to 70%. And keep in mind that this is just a financial standpoint because you have to think also because it was just me doing all this stuff. So try to guess and try to imagine how many hours and how many people do you need in your organization to run such an infrastructure. Well, with Kamaji, since everything is automated, obviously, I'm a bit biased about that, but we can talk about that. But you have all the machinery to run on your own. So, should I do it? That's the most important thing, and it depends. I mean, obviously, this is an extreme use case, but we had the chance to talk also with companies that are running on-prem, and Kamaji has been considered for those users. It doesn't mean that you cannot use in the cloud because there is a nice feature because we are running as pods. So it means that what you can do is to turn off the API server so you can save even more. Something really cool because with EKS you cannot do that. You can do it with Azure Kubernetes service so you can turn off and turn on, back and on. So with Kamaji you can do that. But you don't have to talk just about the savings, but what I want to focus is the operational burden. And since we got still time, I can show you what it means with operational burden. We got just minutes. So as you can see here, we're running 124. So what happens if I edit the control plane, changing the version of Kubernetes from 124 to 127? The answer is that you cannot. And the same applies also with Kamaji. So essentially, Kamaji is like having a real colleague that is helping you. But what you can do is then to upgrade. So I can edit again the control plane. I look for the version, and I say, let's go for 125. So now I can see here we are in upgrading state. And what I can do is to use kubectl version, watch -N1. And you can see here, if I'm lucky enough, to don't have any sort of downtime. Obviously, we are downloading the new images because we are using the plain Kubernetes images, but in a matter of seconds, we should have here our new version rolling out. We are just talking about the control plane. Keep in mind, Kamaji is not offering the full cluster because it really depends. You need to bring your own nodes in your preferred way. You can use kubeadm, you can use Terraform, you can use whatever you want. We are totally committed in supporting kubeadm. And essentially that's it. So what happens if I delete the API server certificate? Because take a look here, we got the API server certificate. So kubectl, you know, I want to play with that, delete secret. kubectl gets secret. It has been created back by Kamaji. And you don't have to take care of this. So even if you're committing errors, Kamaji is helping you. And pretty sure we are ending up with the new API endpoint coming up with the updated certificate. So essentially, you can operate at scale because you're not doing that. So keep in mind that Kamaji is Apache 2 licensed, is totally open source, and we got a channel Slack in the Kubernetes workspace. We got a channel that is named #Kamaji. So this is also the GitHub repository, and you can get in touch with me using this email. And I'm part of Classics, and we are running also some virtual meetups about multi-tenancy in every shade. This is also our GitHub repository, and if you have any question, I'm really happy to try to answer them. Thanks.
Thank you very much. We have some questions. The first one is, why is PostgreSQL preferable to MySQL?
Nice question. So the problem of etcd is the fact that we got some issues, especially running at scale. If you take a look to the official documentation, they are saying that a database bigger than 8 GB, it could be really a huge problem because they don't know what's going to happen. Hic sunt leones. I'm from Italy. I use a lot of Latinism. With PostgreSQL instead, we are taking advantage of a nice project that has been developed by the Rancher people, by the K3S people, that is named Kine, K-I-N-E, that essentially it's an etcd shim. So it's an adapter that is sitting in front of the API, well, not in front, but in front of the data store, and is translating the gRPC calls from etcd to the dialect. And using PostgreSQL is that I'm not saying that PostgreSQL is easier than etcd, but you can put in place something really interesting because with PostgreSQL, you can have an active and passive replication in the same cluster. But what you can do is also having an asynchronous replication between different sites, even a geo-replica. So it means that what you can do is to have the unknowledge in the same cluster, that is the active cluster, and then you can replicate the data in async mode to the backup site. So you're ending up with an application level disaster recovery aware infrastructure, something that with etcd you cannot do that because you need to do that at the infrastructure level. So the cloud native pattern, if you think about that, and I forgot to say that also Kamaji, is everything declarative, so there is no imperative way. So it means that it's GitOps ready. You can put in place your automation. And the same applies also with Cloud Native PG, that is the project that is running PostgreSQL database inside of Kubernetes. So you're ending up with managing the full life cycle, also about the storage of your Kubernetes cluster at the application level rather than the infrastructure level. Because at the infrastructure level, it means that the application is not aware when a database is starting. So PostgreSQL, it doesn't know when to stop the writes, because otherwise you're ending up with an inconsistent backup. I hope I answered your question.
Thank you. Next question. How does Classics ensure that the activities of one tenant don't impact the performance of others in a shared cluster?
Yeah, it really depends on what you want to achieve. Keep in mind that we saw people that is running one data store per tenant control plane, but if you're running with PostgreSQL, essentially we are creating a different user. And with PostgreSQL, you can put a sort of quality of service. So you can say you cannot write so many items at the same time. So it's, I don't remember the parameter, but there is the configuration where you're creating the users to say you cannot write more than X items per second, something like that. So you're shifting the quality of service to the data store level. And unfortunately, with etcd, as far as I know, I'm happy to be corrected, you cannot achieve that.
Thank you. The next question was probably already answered. Why are you against running MySQL?
I'm a bit biased about that, I'm sorry, but I don't like it so much, MySQL, because with PostgreSQL, it's slightly more complicated, but you can do more interesting stuff.
Thank you. The next question, how does running database on Kubernetes cluster affect performance?
This is really complicated because, I'm trying to engage with the community, because I really love Kubernetes because it changed my life in the worst, I'd say. But it's a different story. But it's not a matter of performances because if you think about databases, containers, essentially, if you're running MySQL or any database, as a systemd unit, essentially that's a process. And a container is essentially a process. But the real bottleneck is the storage. And unfortunately, but it really depends also on the storage you're picking up for your Kubernetes cluster, it means that you could write maybe on an FS share. My gosh, running databases on FS would be really awful. But it's up to the implementation. So the Cloud Native PG, and that's the project I'm a big fan and supporter, essentially they are suggesting to use local path provisioner. So it means that you're eliminating the translation of the calls because you're using a totally compliant POSIX and they are managing the application, well, the backup and the writes and also the read at the application level. And essentially you're not ending up with performances issues. But I would say that if you're looking for performances, you're not going to use Kubernetes because there are so many not limitations, but just think about the networking. You can think about the IP tables issues if you're looking for really, really performant network. So you're not going to use Kubernetes for high performance stuff. My 2 cents. I'm a bit biased.
Thank you. And the last question so far, can you use Terraform with Kamaji?
We have a roadmap, also because keep in mind that my dream is to donate Kamaji to the CNCF to make it totally open to the world, so with a shared governance. And we got in the, oh my gosh, we got in the roadmap that is public, also the Terraform provider, but I say that it's possible because in the end, you just need to read the state from the Kubernetes API server because the Kamaji instances are defined as custom resource definitions in the Kubernetes API server. So yeah, that's the plan. And we are looking for, besides adopters, but also contributors. We are totally open, and keep in mind that also in regards to the cluster API discussion that we had, we are engaging with the community. It should be Kamaji. Cluster API. We started the discussion here, so you can join, and we are looking for feedback and also to use case. So please try to engage, and I think that I got strong opinions, but weekly held, so I'm really hoping to have your feedback and also any kind of help.
Thank you very much. That concludes our presentation. We have a 15-minute coffee break, and there is another next presentation will be a remote one, so it will be streamed on that screen in here in 12 minutes actually at 3. Thank you.
Thanks.